Well, good afternoon and welcome to the TGAC webinar Breaking Barriers, Laminated Glass Technology and Applications in 2024. Well, laminated glass has a fascinating history that dates back to 1903 in France, where it was invented by the French artist and chemist Eduardo Benedictus. Interestingly, this game-changing material was discovered by pure accident when Eduardo dropped a glass beaker coated with cellulose nitrate, and instead of it shattering, the glass cracked but remained intact. This unexpected discovery led him to successfully patent the invention in 1909. Initially designed to improve automotive safety, laminated glass was introduced to make windshields more resilient against breakage, a crucial advancement after early windshields provided very little protection in accidents. Well, laminated glass has gained widespread use in the automotive industry since 2019, when the Ford Automotive Company, being one of the first manufacturers to adopt it, after Henry Ford himself was injured by shattered glass. And in fact, Guardian Industries, a well-known player in our market here in the Middle East today, and was our guest last webinar, was established in 1932 to supply laminated glass specifically to the Ford Motor Company. Well, laminated glass also plays a significant role during World War I, being used in the military gear such as plane windshields and gas masks due to its shatterproof properties. Well, today it's a requirement for all car windshields and remains a vital material in the construction and automotive sector. Well, in this webinar, we'll discuss how laminated glass is used across the Middle East for its unparalleled safety, acoustic, and environmental benefits. We'll explore the many applications from enhancing building safety to providing UV protection, how it has become a crucial component of modern architectural design in the region, and why it's called the Grade A safety glass in many parts of the world. We're excited to welcome Sarah Coogan, the Regional Director of Inhabit, an Aegis company, as our special guest today. Sarah is a registered architect and an expert facade designer with a wealth of experience in the glass industry. And throughout her career, Sarah has been instrumental in designing innovative facades that push the boundaries of architecture and construction. Her knowledge of glass and facade technology and its practical application has made her a key player in creating sustainable, high-performance building envelopes. We're thrilled to have Sarah on board today and look forward to her sharing her insights on the latest developments in laminated glass and some of the projects that she has designed with laminated glass and how she sees the future role of laminated glass in architecture. And joining us, we also have Wael Hassan, who leads the glass division at Technical Glass and Aluminium, where he plays a pivotal role in driving the company's focus on high-performance insulated glass, a key component in modern in the Middle East region architecture. His deep understanding of an industry experience spanning over 30 years has been instrumental in TGA's decision to expand its production capabilities, including super jumbo glass panel manufacture in the new facility in Dubai. And I'm sure Wael will explain more about that. Staying at the forefront of technological developments, Wael has ensured that TGA remains competitive by fostering strong relationships with suppliers and integrating cutting-edge solutions. His commitment to the company's growth and the advancement of the glass industry has really solidified TGAC's reputation as a leading supplier of high-quality glass products for the Middle East region. And we also have Mazen Ezzedine. He was with us on our last webinar. Mazen, thank you for joining us. He has over a decade of experience at TGAC and serves as the Sales and Operations Manager for the Glass Division. Now, Mazen holds dual bachelor degrees in science, in applied chemistry and analytical chemistry. I only found that out today. I didn't know that he had 2 degrees. I'm not sure if that makes him twice as smart as everybody else, but we will soon find out. But Mazen is deeply committed to mastering the science of glass technology and ensures that his customers receive both expert knowledge and top-tier support. He's passionate about sharing his extensive experience with the industry, with his customers, and pretty much anyone who will listen to him because he doesn't stop talking. Whether it's about cutting-edge glass solutions or innovative technologies, Mazen is the guy who is pushing the boundaries. So I really welcome Mazen, Wael, and Sarah to our panel today. It's great that you could join us. And we're going to hear from each of them, and then we've got some questions to ask simply about the technology of laminated glass and where it's used today. So first, I'd like to push over to Wael. And I was wondering, Wael, if you could explain to us the mechanism of manufacturing glass. What's the production process to make laminated glass? And what are some of the QA/QC testings and considerations that are done in the factory? And maybe you could explain a little bit about the TGAC capability for laminated glass production.
Okay. First of all, hello everyone, and it's great to be here. Thanks for the invite. And thanks to Sarah for joining us also. It's a privilege for us. When first of all, talking about glass lamination process, what we need to understand is basically what it means, and it is basically laminating two pieces or multi-layers of glass together, creating, a strong adhesion together. So we need to know that this is a very sensitive process, and that's why glass lamination is always done in a weather-controlled room, controlling humidity and temperature. And these rooms are known in our industry as the clean room or clean rooms. Now, the PVBs and SGPs are also always stored in weather-controlled stores to make sure that no humidity will form on the PVB layers or, of course, the SGP layers. Now, basically, glass, in whatever process that it goes through, it needs to be cut, and then after, following its journey, after every process, it needs to be washed. So before going to laminated process, the glass, if it needs to be heat treated, needs to be going into a heat treatment furnace to get it tempered or heat strengthened. Or if it's not, it will just be in its annealed form, and then again, it needs to be washed, and it goes into an assembly room where it's weather controlled, like we said, and two or multi-layer glasses are put together with a PVB or an SGP interlayer in between. And then it goes into a pressing process, called a nip roll. The technical word is nip roll, and this exerts pressure on glass together with heat to get the initial bonding of these glasses together. And afterwards, when that's done, that's not the end of it. It has to go into a autoclave, which is basically a vacuum room where glass, where this ensures under big pressure, around 12 to 13 bars, the glass will bond to each other for good, and that makes sure, this process makes sure that all air is removed between the layers of the glass, so there will be no air bubbles whatsoever. Now, this is said in a very simple form, but laminated glass is very essential, mainly for safety and structural reasons. And I will leave that for Mazen to talk about different products that are used in for that lamination is used for, like bullet glass, bullet resistant glass, burglary resistant glass, balustrades, different kinds of decorative laminated glasses, and so on. So yeah, that's in a nutshell, that's what it is. Now we always do our internal testings in TGAC, to just make sure that quality is always controlled from the PVBs before and after the lamination process. We do, in our internal labs, we do bake tests and we do freezing tests and we do the ball drop test. We follow, of course, the international standards where we make sure that they abide at the minimum of the international standards, but usually we achieve much higher specs in terms of strength and durability. Now, to give you if you allow me, to give you a little bit of a background on technical glass capability, the glass factory in Jabal Ali is a 4-year-old factory. In fact, October 2020 is when we kicked off and started production in Jabal Ali. We are 33 now years old. We started in Sharjah. In this factory, we can do mega sizes, 12 meters by 3.3 meters, 12 meters in height, and 3.3 meters in width, in terms of all processes, from cutting to pre-processing, edge works, then tempering or heat strengthening, and then lamination and double glazing, and even triple glazing. So, and to go back to the lamination, we can do up to 100 mm thickness, which then again, such high thicknesses will result in glasses like, again, bullet resistant and burglary and blast proof and all these safety types of glasses. So yeah, that's about it. I mean, I would, we'll welcome questions later, and I'll go back to you, Phil.
I will say that Technical Glass and Aluminium's new factory is just designed to produce jumbo everything, from laminated glass, tempered glass, IG units, even ceramic printing. The entire factory is designed to produce jumbo size, and that in itself is unique when you compare glass factories all around the world, and definitely here in the Middle East region. So Mazen, I was wondering if you could jump in and if you could share with us some of the applications that TGAC have supplied glass for, and where it's been used, and what are some of the projects that you have installed your product, your laminated glass for.
Thank you, Phil. Thank you, Wael, Sarah. It's a privilege to have you with us on this second webinar. Thank you, Phil, for the presentation. Puts a big pressure on my shoulders, big load on my shoulders. Thank you for this.
That's a lot more than me.
It's great to be here again on this second webinar as a follow-up to the first one that we've done with Guardian Industries, where we basically attend to a very important and extremely sensitive topic of laminated glass. Now, the TGAC is obviously one of the leading glass processors in the region, and with operations since 1989. And we've been regularly supplying glass for different projects in the region, locally and internationally. And laminated glass has been part of this supply, an integral part of this supply in different uses, different solutions. Our laminated glass and double glass units, of course, in general, glass in general, has been used and has been supplied to many, really, of the prestigious projects across the region. Again, whether it is in the UAE, or in the region in general. And of course, I would like to showcase some of the projects that we've done, some of the iconic projects, of course, that we've done, which were, just to mention, those projects have been supplied as glass and have been glazed, actually installed in partnership with our aluminium division in the group of Technical Glass and Aluminium Company, where we can provide full solution for the facade industry, really. So just starting with a few of the projects that we've supplied that have included the laminated glass, basically. First one is the one at the Palm by Niyat on Palm Jumeirah, a very iconic project. Super jumbo panels, where obviously the use of laminated glass becomes an integral part due to the size, due to the structural calculation needed, where laminated glass becomes part of the safety that is needed for those glasses. One of the iconic projects. Of course, we have the Qattara Twin Tower, one of the recent additions to the iconic projects we've done. This is actually in Doha, in Qatar. It was an integral part in hosting the FIFA World Cup in Doha. 2 hotels, 2 towers connected with a huge podium, super jumbo panels, laminated outer and inner panels, balustrades, SGP, PVB applications, the full range of products really on this project. The Doha Oasis, again, another key project, another prestigious project. All the balustrades, many of the floors have been done with laminated glasses based on what the requirement and what the facade requirements required really with the Doha Oasis. The Greek Harbor area, where I can proudly say that more than 70% possibly of the glass supplied to the Greek Harbor area has been supplied by Technical Glass, different projects, different customers. This is one of them, the Creek Edge. Many of the floors, depending on the elevation, because in some cases certain elevations require certain acoustic requirements, and accordingly laminated glass had to be used on the Creek Edge. Marsa Al Arab, and I'm talking specifically on the Quay Villas, 9 high-end villas supplied by Technical Glass, glazed by Technical Glass Aluminium Division, again balustrades, and some of the elevations have been done with laminated glass, insulated double glass. Again, in Creek Harbor, the Icon Bay, up to certain floors, certain elevations, the full insulated glass panels have been done with laminated glass as well as the glass balustrades. Qatar Faculty of Islamic Studies, one of the most complicated, one of the most prestigious projects that Technical Glass has proudly supplied and glazed. This is a university basically for Islamic studies. And again, the glazing of the projects had a lot of laminated glass that needs to be incorporated. Moving on, the St. Regis Oman, a recent addition as well, a 5-star hotel in Muscat, Oman. Full glazing for this project was done with laminated glass, again to achieve the acoustic comfort inside the rooms where usually is required with such projects. Yas Marina Formula One circuit, of course, just to mention, as we're mentioning Formula One, I'd like to mention briefly that the Yas Marina Formula circuit has been part of it supplied by Technical Glass. The Doha Formula circuit has been supplied by Technical Glass, and the Jeddah Formula One circuit has been supplied by Technical Glass as well. Here, there were a lot of requirements that had to do, especially with safety, especially on the balustrade, separating certain areas where the use of laminated SGP interlayers had to be supplied. Creek Gate, again, another project in the Creek Harbor. Same thing, same story, elevations with laminated glass and balustrade with laminated glass. The Wassel Tower, I'm sure all of us know now about the Wassel Tower, shaping up in the last 95% completion. We're about to hand over this project, a super complicated, twisted tower, shaped panels. All this project has been glazed with laminated glass, outer panel, and in some cases inner panels. All this project has been done with laminated glass with an extreme complexity, but proudly achieved and supplied on time. Masdar City Campus, the same thing, laminated glass, supplied to certain areas to achieve the acoustic requirements in Masdar City in Abu Dhabi. Sidra Medical and Research Center in Doha. This project was not only supplied and glazed by Technical Glass, but fully engineered as well by Technical Glass with special systems that had to be supplied to achieve the requirements, the facade requirements for this project, and a lot of use of laminated glass and a lot of internal aspects and the external facade as well. Panda House, this is a project in Doha where Doha built a zoo basically for two pandas in an attempt to, protect this species basically. And of course, when we're talking about zoos, when we're talking about animal shelters, there's a huge requirement for laminated glass required for safety and certain access to certain areas. Fairmont Resort in Dubai as well, balustrades and double glazed panels in certain areas and certain elevations had the use of laminated glass. The same with Abu Dhabi Islamic Bank, whether it is with the internal package or the external package as well. The main facade, some areas had been done with laminated glass. At W Hotel on the Palm, again, it's a full facade with glass, fully glazed. All the balustrades done by technical glass, full laminated package, and as well as some of the elevations with double glazed laminated panels. And the Four Seasons in the IFC, the same thing basically. Again, all these projects have been supplied and glazed by our aluminum division as well, installation on sites. And the Dubai Creek Harbor, the first 6 towers that were installed on the Creek Harbor area, the first 6 completed buildings were done by technical glass in both laminated and double glazed panels. Now, I'd like just to give a brief about the different solutions that we can provide using laminated glass panels. Of course, with this solution, with this invention of laminated glass and laminated films, solutions have been regularly, inventors have been coming up regularly with different solutions to provide different aspects to facades and to facade specialists. One of the main uses of laminated glass is when it comes to bullet resistant, providing full security across different range of weapons or arms to protect certain areas, whether we're moving from BR3 up to BR7. Here we're talking about multi-laminated glass panels to different thicknesses that can reach with the bullet resistance up to around 80 mm, 8 centimeters glass thick, multiple layers of glass laminated with each other using both PVB and SGP, and to provide this security solution. And of course, all these things comes with certificates. Tests have to be done to provide these solutions, as well as anti-theft or anti-burglary solutions of laminated glass. Again, this is being used a lot in shopping malls or in certain brands that require, whether it is jewelry or high-end brands that require certain protection. It's not the level of a bulletproof, but it's definitely an anti-theft laminated glass where thieves cannot break in, basically, to access these places. As I said, certain elevations sometimes on projects or certain projects where they are in the proximity of airports, highways, where there is a high level of noise pollution, basically, and to provide comfort for the residences, for the offices, whatever buildings are being used for, we can move from a normal laminated glass to an acoustic laminated glass using a different kind of interlayer called an acoustic PVB to achieve a better sound comfort inside the buildings. Again, this can be supplied by technical glass to achieve the dB required on those elevations or those solutions. Colored PVB lamination can be provided. Interlayers can come, especially the PVB. The SGP is still limited to basically either clear or in a white solution. But with the PVBs, we can achieve different colors, different range of colors. We can even work with our suppliers, the international suppliers that we work with, grade A suppliers, to achieve certain colors that are required on the building. So these different kind of colors on facades can be achieved using interlayers, colored interlayers. Again, another solution in many requirements, and this is widely used in interior packages where there's a certain need for a mesh, a fabric to be sandwiched between the two panels of glass. This can be done using the laminated glass technology, Usually such an interlayer, whether it is a mesh or a fabric, is sandwiched between the two glass and between two SGP layers. Really, in most cases, it has to be SGP to achieve the adhesion, but all these solutions can be done using laminated glass technology, and technical glass obviously can provide all these solutions. So that's basically more or less just to showcase some of the projects and some of those solutions that we can provide from technical glass. Thank you, Phil. Back to you.
Well, thank you, Mazen. Nice introduction. You both you and Wal mentioned PDB and SGP. I hope we can unpack that a little bit later to explain what those differences are, and I'm sure that those questions will come up. But I really look forward to hearing from Sarah this afternoon. And it's so good to have another Australian on our webinar show. So welcome, Sarah. It's great. It's great for you to be with us. Sarah, I was wondering if you could just talk to us a little bit about the projects that you have worked with, where you have specified laminated glass, and if you could show us a few of those applications, just to help us understand, as a designer, what it is that you're looking for when you're specifying laminated glass products.
Sure. Thanks very much, Philip. And thanks, Mazen and Well, for the introduction and invitation, actually, to come and have a chat. I come from a facade consultancy background, so we're primarily involved in the front end of the design process. So we work with engineers and architects to specify and develop systems that can work on the facades. So we are the ones that are engineering the glass and specifying the glass and developing the details so that they can be produced by the glass factories. If I could just take the opportunity to run you through a few projects and how we've used lamination in our various projects. So I just want to take you through a few different projects where we have used lamination in the design process and how these have been executed on site. This particular project is the One Zabil project, and this particular photo is almost like the hero shot at the end of the bridge. It's a very famous, iconic building in Dubai, and it's very iconic for using glass in a number of different ways. In this particular image, you can see several instances of laminated glass that have been used, and it may not immediately be obvious of how they've been used in the design process. If I could start with the top, we have elements with the double glazing as part of the vertical facades. This is all laminated glass as part of the double glazed construction. We have vertical glass fins, which I'll take you through. We have a trafficable glass floor where the glass is acting as a structural walkable layer. And we have elements of skylights and glazed soffits, all of which include components of lamination. When we're looking at lamination, we're looking at it both from technical and from aesthetic point of view. So here is an example of how we might look to use lamination as part of a glass fin. This is an external glass fin in this particular case, and it's looking to use ceramic frits that are included as part of the laminated panel. This you can see has been checked in terms of the colour of the frits and also in terms of the mock-up for the spacing of the pattern. And this is part of the process of not only just specifying but also undertaking mock-ups, both visual and performance, to check that it's working both aesthetically and technically. In terms of another non-performance element, we were involved in the City Walk project. So this particular facade is quite iconic. I think a lot of people would recognise it. And this is using laminated glass construction with what we call as a dichromatic interlayer. Technical glass discussed some different types of interlayers that are available, both in terms of meshes, patterned elements, coloured, etc. This is a transparent film which essentially changes colour within a colour range and spectrum. So it's a static element, but depending on the viewing angle is how you see the change in the colour. And this is also further amplified by the fact it's like a chevron profile. So you are seeing multiple angles of that laminated glass, which helps give this multi-dichromatic effect. In terms of lamination on towers, In this particular case, this is again the Ones to Build project. We have used lamination in 2 cases on the main tower. So you will see the double glaze unit, which is forming the building envelope. The outer light is using lamination. This is because it's a grade A building. The lamination in this case was used both for acoustics and for wind. And it was also used and put on the outside of the building because it's part of the post-breakage glass retention. So in the unlikely event of glass failure, it's all retained in place before it could be replaced. You will also notice with the lamination, we try and put the thicker on the outside of the double glaze unit, and that's just to control some of the visual distortion issues that you can sometimes get. That's a preference from design side. I know contractors sometimes like different approaches, but this is how we generally think about things. Also, where we have lamination as part of the double glazed units, we also have to think about where the soft coating is for the performance coating on the glass. And there's different combinations that can be done, but generally the soft coat is still on surface 4 of the glazing from most of these kind of configurations. In the plan detail, you'll also be able to see that there is a external glass fin arrangement, and this is also actually acting structurally. It's providing by reducing the depth of the mullion, and it's also providing some shading elements to the space in behind. So in this instance, we've used lamination in kind of 2 applications. Additionally, you often see lamination used in glass fin construction, and there's been a whole range and evolution of glass fins. You can see the more traditional ones with glass fins with spider fixings, which are probably slightly older generation. With these types, the glass fins would always have to be fully tempered, and the reason being is one is for the structural integrity, but also when you're drilling the glass, we need to ensure that it's a fully tempered laminated piece of glass, and the drilling can only be done on the fully tempered. In this particular instance, we've used a low iron glass with a Sentry interlayer. There's a few decisions here. One is the low iron glass helps is often used externally on balustrades, but in glass fins it works very well, because otherwise if we were to use clear glass, you would get almost like a compound effect of slight greenness, which is often not ideal for showcase elements. In this particular instance, we've also looked at introducing steel or stainless steel splice plates and some rod arrangements, and this is helping to prevent buckling. The splice plate in this case is also helping because the span of this was something like 22 metres, this glass fin, which is obviously a considerably tall element. Laminated glass, more traditionally, has been taken up to probably the 7-metre range when this was designed. But we know certainly now, we've seen from some of the factory capabilities with TGAC that there's definitely been increases to that. And so there's been further opportunities to push the boundaries in terms of those lengths. Obviously, this also depends on handling and erection, and sometimes it's simpler to have slightly smaller lengths that can be lifted up. Again, in the plan detail, you will identify that we've also got lamination on the outside of the double glazing. This is a particularly interesting item. This is a glass trafficable floor. So whereas we're usually doing with facades that are forming the building envelope, and these are the elements that are watertight, airtight, thermal elements. In this case, there was a section of this project that required a trafficable glass floor to obviously be as transparent as possible to look down through a glass soffit. So some of the design considerations include we have a twin fin, we call, which is supported off a steel diagrid structure. This is all low iron construction, so we don't get any compound effects looking through the glass. And also the top layer of the glass that is trafficable is also a number of lights of glass, so it's a multi-layer construction. And this is because it's actually taking the load for live loads of people walking on that floor. In terms of how we look at lamination, in terms of optimization, not all towers will have lamination on the outer facades. In fact, it's quite common to have monolithic. But in many cases, we look to use lamination for areas where we might have high wind load, which is often at the corners of the building. And also functionally, if there's certain bits of the building that need more acoustic isolation, A good example is things like hotels or hospitals, where there may be more a higher requirement for privacy. Also facades that might be facing busy roads, etc. So when we're looking at the design of particularly towers, we're looking at how we can be efficient in the execution of the glass, as not to pick a single glass type that would be used throughout. Here is a reference project. This is a Palm Tower that we worked on, where you can see within the tower itself, we'd identified a number of different types of glass constructions, and we tendered these with elevations to show how they are put on the building. And whilst they're different constructions, we're careful in terms of where we put the lamination and the soft coatings, so that when you look at the tower in the finished state, that it looks homogeneous and that you're not seeing minor discrepancies in colour or build-ups in the glass where we're changing between these thicknesses. I think lastly, we also have a strong acoustic focus within this practice. So whilst acoustics is used, the lamination is used for acoustics, a lot of it is supported by data from the glass suppliers, which you'll see on the left. And this is traditionally done by laboratory testing. So a certain size configuration and a certain glazing configuration will be tested. You can see an example of a reference project here. Obviously, there's a number of different variables: reverberation times, size of chamber, size of panel of glass, and all of these parameters need to be taken into account when looking explicitly at technical data on the glazing. And lastly, I think not only is it important to have this information from laboratory or desktop studies, but it is also important to check that it gets executed at site and is giving the same results, or at least an acceptance of what is allowable in terms of any reductions from site conditions. So the images on your right are more from field testing, of where we have gone to check that the final configuration of the glass in the frame is achieving what the design values that we expected. I think very lastly, there's often a lot of discussion in terms of visual qualities on glass. Lamination is often areas where you have lamination is often susceptible to comments because of either pairing or etc., how it could be put on the building. And as part of our design process and as part of the execution process in terms of reviewing mock-ups, we look at implementing things like Hadamar. There are other ones in the industry, but this is something that we look internally at. So we're looking at not just for lamination, but the general appearance of the glass, where we will look at things like blemishes, dots, pinholes, etc., and what is allowable. The photo on the left is an actual example where we've finished pieces of glass have been taken outside and lifted up with JCB and checked in the actual orientation to see, if the quality is acceptable, and using checklists, etc., to check that that is within an allowable range. I think that's about it for me, Phil. If you've got any more questions, or
I'm sure that we have a lot of questions, but if you could stop sharing your screen, and if I could ask Mazen and Wael to join us and share their video and unmute themselves, because I've got a lot of questions. Now, first of all, for everyone watching, we put together this series of discussions about glass to help the industry be educated, reaching out to architects, junior architects, those that are studying architecture, those that are new to the glass industry. I'm an old glass guy, so is Wael, and Mazen's almost old. But we've been around for a long time, so we've had the opportunity to learn over time. But there are new people entering the industry all the time. And so one of the reasons that we put this series together is to just help them, as a support to the industry, be educated. And we came across a lot of questions from our last webinar that were asked about PVB and certain subjects. And so as we progress, we'll take just different elements of the glass industry and discuss it. And while I know a little bit about glass, I'm going to put my I don't know anything about glass hat on today so that I can ask a few questions that can help us unpack a little bit more understanding about polyvinyl butyl. That's what PVB stands for, and laminated glass, and just so that we can understand from the ground up what it is that we're talking about. So the first question that I have, well, I'd like you to answer if you could. I hear often this term 638, 1038, 1076. What does this mean? When we're talking about laminated glass, how do we understand what this terminology is?
Well, this is probably the composition, the makeup of the laminated panels, where you would say something like the most common one would be a 664, and that means a 6 mm with a 6 mm and a 4 interlayer, which achieves a 1.52. Each interlayer is a 0.38 mm interlayer. So I think that's what it is.
Okay, so you can have different thicknesses of interlayer. What would be the purpose of having a different thickness of interlayer? What's the difference between 0.38 and 0.76 or 1.52? What's this purpose?
Well, basically, it's a spec that is laid for the purpose of safety or even acoustic purposes. The thicker the interlayers are, the more the strength would be, of course, and again, the thicker it is, the more acoustic it would be, So basically that's it. And, with big glass, you have to go with more interlayers to make sure that the adhesion is strong enough and the glass withstands whatever it has to withstand, like wind loads or impact sometimes. This is basically what it is.
So earlier in our discussion, maybe Mazen can jump in here, but anyone's free to jump in. But early in your presentations, you were talking about PVB and SGP. What does this mean? Are there different types of interlayers that can be used in the lamination process?
As I mentioned previously, Phil, yes, there are different types of interlayers used to achieve different solutions or requirements that are set and specified by the facade consultant, sometimes requested by the client. The normal, usual ones that are typically used, more or less, we have the PVB, which is the normal, basic PVB that can give you an advantage when it comes to some acoustic requirements. It can give you a structure, a better structure for the unit, really, when there's a certain wind load that needs to be achieved. Now, of course, when it comes to a more advanced, more security, a better structural calculation, more resistant to wind load, live load, all these things, then we might move towards a more stiff requirement for an interlayer. And here we come to the use of SGP. SGP is a structural interlayer. Basically, it will give you definitely much more strength than the PVB itself. Just a normal small example that we always use in case you have two laminated panels, one with PVB and one with SGP. And if they broke, the PVB, the glass that is laminated using PVB can be bent easily, while the glass that is laminated using SGP will stand still and will not bend. And just a small example for example, on the misuse sometimes of the interlayers. There's a very famous video of a football stadium in Oman where the wrong interlayer was used on the balustrades, separating the crowd from the bottom stadium or seating area, let's say. And at certain point, the whole crowd rushed to the balustrades and put a big live load on the balustrades, and they actually broke. And because of the use of the wrong interlayer PVB, the whole glass bent and people were falling off. So this is an example on how to use a stiff, more structural, more strong interlayer like the SGP can be used instead of PVB. One more very important thing, especially talking about a region like the UAE or the Gulf region, where we are subject to extreme weather conditions, whether it is with temperature or with the humidity, really. And here we can talk about warranties, basically, because PVB is not the right interlayer to use on external balustrades with exposed edges, because the PVB tends to absorb humidity much more higher than the SGP, and this will lead to the product failing with time, and then you will start having the delamination and the failure, basically. So that's why when we talk about external panels, exposed panels, we are always strict with our suggestions and advice to clients to use an SGP interlayer instead of PVB interlayer. One more thing that Sarah was referring to was the walkable areas, where you have trafficable areas, people walking on glass. And here you definitely need a more structural, more stiff, more strong interlayer, such the SGP that can carry such a live load passing on the glass. Now, of course, having said all these things, there is a major difference when it comes to pricing as well between the two interlayers. Yes.
Mazen, thank you very much. Yeah, I had no idea that you had a degree in chemistry today. I was quite impressed when I saw that. I didn't know that, but
one of the passions, you know.
It is very good.
Yeah.
Well, thank you. I mean, there's also another couple of types of laminated glass that I've seen in my career. Resin laminate, which is a resin that's used to bond the two panels together. I don't see a lot of that use here in this region, but I do understand that it is something that is used extensively when you have curved laminated glass. So some people use that. It's a curing resin where you can use it to bond the two panels of glass together. And EVA, which is another type of interlayer that doesn't require the autoclave. It's just a heating process that allows it to bond the two surfaces together. And so I know these are not laminating techniques that you have in TGAC, but just so that we can understand it. I'd just like to hook over to Sarah. We're talking about PVB and SGP. Is this something that you understand as a facade specialist? Are you specifying SGP for a specific purpose? And is this something that is of great interest to you, knowing that PVB has some limitations that SGP can bring value to in the project design?
Yeah, I see it a lot. I think Mazen touched on it well. We use it where there is a structural implication or a weathering implication for the glass. Particularly for things like balustrades. I think that's a good example. Whilst we can, there's two schools of thought. It is not uncommon to have balustrades with capping on the tops of the glass, and this provides a small amount of protection to the edges of laminates. But obviously, if you've got exposed edges, best practice would be to have SGB interlayers. However, we do find on a lot of these multi-story residential towers, there's a lot of cost pressures, and there is a lot of pressure from the market to look at using PVBs in some instances. As Mazen also mentioned, we'll look to use it, of course, always on things like structural glass fins, trafficable floors, elements that are exposed with the edges or subject to high heat. So this is where we would choose to use it, but we wouldn't be using it as the dominant condition is what we tend to find. There might be something like 20% SGP to 80% PVB, something like this in terms of a specification ratio.
Are you, I mean, do you, as an engineer, and you design the project and you're very much involved in the practical installation, is there a concern for your specification being substituted today for a different product? Is this something that you stay close with, and I'm sure it's one reason why you prefer working with technical glass and aluminium, because we do deliver. But is this a concern for the industry?
I think it is often a concern, and not just in glass. There's often substitution through supply chain, which is why it's important, I guess, from the outside, from when we're getting material submittals, that we properly see the supply chain in terms of it's not just a matter of ticking off a piece of glass. We're looking at the coatings, the supply chain of the PVBs, the processes, other processes, approved with this particular coating, this type of thing. So it's more due diligence to it than just as a matter of rubber stamping a piece of 6mm glass. We're also looking at the heat treatment and the internal QA/QC processes during the production, because ultimately, particularly on towers or showcase elements, there's an expectation of a level of quality that the client's looking for in terms of flatness or uniformity of the product. So it's important to ensure that's dealt with as part of, I think, the submittals and the QA/QC processes.
Because I'm sure SGP...
I'd like to add, just Phil, to what Sarah said and how Wael started his presentation as well, because to achieve the right product, to achieve the top quality product, yes, you must have a perfect lamination setting, experienced operators, and all these things. But a huge integral part also of the lamination process is having the right heat treatment process done perfectly. And here it's about what kind of furnaces you have, the quality of the furnaces you have, and the quality of the operators running those furnaces. Because a very integral part in achieving a good lamination quality is the flatness of the glass. When glass comes out of the tempering or heat strengthening, the glass tends to have some kinds of physical distortion with a slight curviness after the treatment. And being able to control this to a perfect place will allow you to produce a perfect laminated glass as well, because always the edges are the most sensitive part of the glass after tempering and into lamination.
That's an interesting point that you raised, tempered laminated glass. Most of the product that I see in the Middle East region, laminated glass, is tempered and laminated. I actually remember when it wasn't possible to temper and laminate. The technical ability just didn't exist years ago. I mean, that's a lot of years ago, right? And so we saw this introduced to the market as a product. But here in the Middle East, most of the laminated glass we see is tempered because it's used in balustrades and that sort of thing. But just for the knowledge of those that are joining us, in many parts of the world, annealed laminated glass is used extensively as a window glass, and it's supplied in stock sheets, it's cut in the glass factory, and it's installed in an annealed form. We don't use a lot of annealed glass in this region. Sarah, I'm sure you're a girl from Tassie, from Tasmania. I'm sure you've seen annealed laminated glass installed in.
Yeah, I mean we don't see it here at all. I'll be honest. Certainly not used in facade applications. Maybe used on showcase elements or gallery elements, something where you need particularly flat glass for non-heat treated glass to get very good optical flatness. I would actually disagree with you. I'd say most of the glass here is heat-strengthened laminate, at least from our side at least, because that still satisfies building code in terms of, if we're talking about balustrades, it's still satisfying the safety glass requirements.
Could we discuss this a little bit more? Because people may not understand the difference here. So we're talking about heat-treated glass, and so in the heat treatment process, we have heat-strengthened and tempered glass, and so we could laminate both. So why would you have heat strengthened as opposed to tempered glass? Why does Inhabit specify heat strengthened laminated glass?
Generally, it's more than sufficient structurally. It's not to the level of tempered glass, but is certainly a considerable uplift in terms of from annealed glass. Secondly, heat strengthened glass, when it breaks in a certain pattern, so it will tend to break to the edges in larger kind of formats. When it is in a laminated construction, it is held in place, so there's no risk of that, falling off the edge of the building. So the lamination in that respect is, for a balustrade, heat strengthened laminate would be more than sufficient. Fully tempered laminate, as I mentioned, was probably more typically used for us if we have showcase elements such as drilled fins and things that require us to put holes in the glass.
If you're bolting the glass to something else, it would need to be tempered in that particular case.
Yes. Also, in terms of tempered glass, tends to be, there's always this chance of nickel sulfide or breakage risk. And whilst we spec 100% heat soak testing for the glass, which is a mechanism to reduce the risk of breakage, for us, this is why we practice using heat strengthened laminates, because it is code compliant, meets structurally, and it has a certain breakage pattern that is good, for post breakage.
In the earlier days, tempered glass had a lot of roller wave distortion.
Yes.
And heat strengthened glass you're able to manufacture or produce with less roller wave and distortion. Now that's changed quite a lot, I understand, recently. Whale, maybe if you could jump in here and explain this a little bit. The tempering process at TGAC is fantastic. They produce very, very flat tempered glass. Is it possible for you to produce heat strengthened glass even flatter than you do your tempered product?
Of course, heat strengthening will have less roller waves on glass because the temperatures involved are less than during tempering process. So you heat strengthening laminated heat strengthened glass is makes basically a glass processor's life easier to laminate because of the flatness that you can achieve. The more flatness that you can achieve on heat strengthened glass, like what Sarah was saying. If it's not required to be tempered, then it's completely okay to heat strengthen it. And I think aesthetically, in terms of distortion of images on many buildings that we see, heat strengthened glass panels on the external part of the building will give you a better result. Now, the reason why, thank you, for mentioning that technical glass makes very flat tempered glass. It's basically because of firstly, our operators, our staff are normally very well experienced. Most of them are, they've been with us for long years now. And the machinery is top notch. All the machinery in this factory in Jabal Ali are just 3 or 4 years old, like I mentioned. And it's just the cutting edge technology today that's possible to achieve, minimum roller waves. And even with such big glasses, you cannot, when we manufacture very big glass, extra large panels, you cannot, you have to think of quality and flatness because basically all large panels must be laminated, So yeah, but it's the machinery and the people operating them. This is the as the years went by, tempering process has come a long way. With full convection furnaces and many ways to enhance this technology. I just wanted to mention one thing that I forgot to mention actually is that one of the main advantages of laminated glass is also UV protection. The PVB and SGP block almost all of the UV radiation. So it's also very important for many people, like in homes, like villas especially, or hotels. They would, where they really care about the internal furnitures and then the fixtures, where they, they would prefer or even demand sometimes to have laminated glass on their facades because it really does make a big difference with saving their internal furniture, basically. Just to mention that, I thought it's worth mentioning too because it is a big deal for a lot of people.
Well, we really want to keep close to the time. There are a couple of interesting questions that have been raised by the panel.
Yes, I've been more interesting.
Those we will get back to them. But there are a lot of different applications or uses for laminated glass. Jump in here. Tell me some of the areas, some of the interesting considerations that you've used laminated glass for. I'd like to start because one of the best experiences that I had was when I saw a bomb test with laminated glass, and it was fantastic. A 5 kilogram bomb in China blowing up this glass panel fixed to a facade was really interesting, because it the glass stayed together, but it also had to be bonded to the frame because the frame and the glass had to be one unit, and so we've used it there in that instance. But what are some of the other uses that we see for laminated glass in this region?
This is for me.
Yeah, Mazen, jump in. Whoever's first.
Fire.
Fire. And as I said earlier, different solutions, different uses. You spoke about ballistic resistant. We spoke about bullet resistant, anti-theft. All these must be laminated to provide the safety and the security. In certain areas, multi-layers are being used because in case you have one area that broke, the second area broke, the third, so that you can still have some protective areas, panels of the glass, let's say, before the explosion or the bullet can penetrate. So those are many of the uses. For example, as we said, the bulletproof, the anti-theft, ballistic resistant laminated glass. But very, very important point that when you present such solutions, it's not only about the glass. The framing has to be looked at as well, because that's an integral part of that opening to provide that solution. The same as when we talk about fire-rated glass, which can be a topic that we can discuss later in another webinar possibly. But as we said, the framing is an integral part of that opening. If you put just a piece of glass without looking at the steel framing you have to provide, then you're not providing the protection. So those are solutions that are being used. And again, as we said, one more area that we didn't really attend to at all is skylights, for example. Skylights, it's a must that you have a laminated glass, because you're protecting whoever is sitting or walking or whatever under those skylights from the chance of glass breaking and falling down on people. So in terms of skylights, it's a must that you would have a laminated glass. Another use that we've been seeing recently in some of the specs, some of the projects, with the requirement of a digitally printed or certain printing on the facade on surface number one, just to show the real color of the printing you're doing. And if we're talking about a coated glass with the thermal insulation requirements that needs to be achieved, in that case, then the use of laminated glass is a must, because you need to print on the first panel on surface number one, laminated with the other panel, and then the coating, as Sarah was mentioning, will be on surface number 4, fully insulated inside the air gap. So that's another use that's been really, we've been seeing it more and more, where there's a need for a digital printing, digital printed glass on surface number 1. And maybe one of the projects that we could have added on our list we didn't mention is the Qatar Airway accommodation, just a 2 years old project that we fully supplied around 30,000 square meters of facade of glass. And that has been a fully laminated, digital printed outer panel with soft coat on surface number 4. And again, Sarah mentioned something about using the right type of glass for the fins, for example, using a low iron. When we're doing digital printing and laminating, we also advise using yellow iron glass to minimize the greenish effect of the clear float glass. So those are different solutions. Sarah mentioned in certain hotel areas, in certain hospitals, in certain universities maybe, or special use buildings where there is a requirement for an adequate and a proper noise controlled environment inside. That's a must to use laminated glass, acoustic glass, to achieve this sound insulation. One of the questions that are there on the panel is, will a laminated glass provide the same sound insulation as a normal IG glass? Definitely not. The laminated glass will always give you an enhanced a sound reduction, a better sound environment, let's say, and more acoustic insulation.
Yes, so true. It's unless that airspace is at least 100 or 150 large, it doesn't really contribute. You're much better off laminating multiple thicknesses.
Surprisingly, it tends to bounce back when you keep on increasing the airspace. It reaches to a certain point that your sound reduction does not improve anymore, and then sometimes the graph falls down again. So in certain areas, especially when you start looking at above 41 or 42 dBs, then the use of laminated glass becomes a must.
An interesting point you raised there about the frame and the glass, sort of like the bomb test that I saw. It's the same in the hurricane glass.
Yes.
If you're in a hurricane, the negative pressures on the building can actually pull the glass out of the frame, and it flies through the air. It's not that it blows into the building, it actually goes the other way around. I know in certain hurricane areas they've designed laminated glass so that when it breaks it stays together, but it has to be bolted or firmly fixed into the frame. And so in answer to one of the questions from the audience, yes, laminated glass is used in the hurricane, but in consideration to the framing system that is tested and approved, and the hurricane testing laboratory is very interesting, very fascinating. I've actually seen one, so it's very cool. Well, thank you so much. We really, really want to keep to the 1 hour. We don't want to take everyone's time too much here. We appreciate everyone that's joined us today. We will be recording this. It will be available for review on our YouTube channel. We'll share the presentation with those that have joined us. So thank you so much for taking the time to be with us. But just, I guess, in closing, I was wondering if we could just talk about some of the advantages for TGAC and your laminated process, quality and confidence and lead time. Maybe, Wael, if you could just briefly give us why would somebody buy glass from Technical Glass and Aluminium today?
Like we were stressing all the time, the quality is very important. And we do find it very essential to always stick to standards. And, we try to always make sure that we deliver, glasses up to the standards and up to the specifications that projects have. The other thing is I think Technical Glass has proven throughout 30 plus years our capability to deliver on time within the specific time frame that we're given. Big or small projects, we're very flexible, and after sales, there's we're all very well accessible by our customers. All of us, we have a staff of around 35 or maybe now 40 administrative staff. So, people feel comfortable reaching. Of course, different customers have different account managers. And, and plus the QC, we have a big team of QC. So after sales, whenever anything comes up, needs to be seen on site, sometimes reports. So, that in a nutshell, the whole thing, it just makes sense. And that's what keeps us going. And we're proud of that, and we're thankful to all our customers.
And you should be. I think it's wonderful that Technical Glass has continued to invest in their operations, not just to grow their company, but to provide the services that are necessary. No one was using jumbo-sized glass in the region. You stepped up and, made the impossible possible. And I'm sure that that's a continued success for you. But having the size of the factory servicing your own requirements and that of the industry, and to have that available in all products, not just laminated glass or not just tempered glass, but everything that you can produce in a very large size. And I'm sure that contributes to and will continue to contribute to your success. Well, thank you so much for joining us. Sarah, thank you for being our special guest today.
Thank you, Sarah.
Appreciate it. And it's wonderful that you could take the time to be with us today. One of my favorite projects that Technical Glass and Aluminium have supplied and installed is the roller coaster project in Dubai. I think that's a great building, and the interior shots of that. I know that I understand that Inhabit was involved with the engineering of that project.
You were the consultant on that project. PJC were in the contractor for that.
Well, thank you very much. Thank you for your commitment and support to the industry, Sarah, here. We hope you continue to design fantastic facades. I'm sure there's a lot of project activity in the UAE and Saudi Arabia at this time, really driving the market forward. And it's exciting times here in the region for the construction industry. So thank you for joining us. Thank you for contributing our panel. And we look forward to catching up with you on our next webinar. I have no idea what we're going to talk about on the next webinar, but we will let you know shortly. So
we'll put it together, Phil, for sure, as always.
Thank you so much. Have a wonderful day.
Thank you, guys.
Bye.
Bye-bye. Bye.